All right, so we're going to look at 1.7 functions. So before we looked at relations, and relations was a set of ordered pairs, and then we could graph them, we could make tables and all that stuff. Functions are now basically, we're analyzing the graph of the relations, and particularly, kind of looking more into the ordered pairs. So our goals are to determine whether a relation is a function, and then to determine the value through function notation. All right, and we'll talk more about that function notation. That's the one that's going to be big here. So again, all you need to do in your notes, just write 1.7 functions. You don't need to write down the goals. I explain the goals just so that you have an idea of what we're going to learn today. So a function, I recommend you to write down this definition. A function is a relationship where every input, which is 9 times out of 10 an x, has exactly one output, which is most of the time a y, because again, we're talking about our ordered pairs. So again, a function, basically every input has one output. What it means is if you input one number, you're going to get only one type of number out, all right, and everything. So if we look at these two graphs that we have here, I have a third one too that we'll talk about. Both of these graphs are a function. And how I know they are a function, they pass the vertical line test. What do I mean by that? I mean, if I take a vertical line, so I'm going to minimize this so I can create a vertical line. So if I create just a random vertical line straight up and down, all right, and I move this vertical line wherever on this graph, this vertical line will only touch the blue line one time. So as you can see, I'm taking this vertical line and it only touches the blue line one time. If I look at this one, as I'm moving it through, it only touches that blue line one time. So by looking at a graph, we can determine if it's a function just by using the vertical line test. If it passes the vertical line test, it is a function. And I said there's a third graph, and I want to show you guys. So if we look here, and we take our vertical line, as you can see, this vertical line touches the graph twice. And that's the example of that orange dotted that. So this one is not a function because it does not pass the vertical line test. All right. So again, these two are a function because they pass the vertical line test, This one is not a function because it does not pass the vertical line test because that vertical line hits the graph twice. So that's the easy way you can look at that. So this is basically a function looking at it in graph form. We can determine if it's a function or not by determining whether it passes the vertical line test. Now the next part we're going to look at is what's called function notation. Now you see two different things up here. We have an equation and we have function notation. This is going to be a little bit new for you guys. So this is an equation, y equals 3x minus 8. All right. Yes, we're seeing two variables in here. But what we can do is we can kind of cover up the y equals, and we have 3x minus 8. You guys should be familiar with that. Well, normally with substitution, we can solve for x equals 2, or they can give it to us. So what I can do is I can substitute this 2 in place for the x. And then I would be left with y equals 3 times 2 minus 8. Okay, so now let's solve. Let's do the math on the right side. So y equals 3 times 2 is 6 minus 8. 6 minus 8 is negative 2. Oh, that's a 6. Sorry. 6 minus 8 is negative 2. So what this means is when I input a 2 in for x, the only output is a negative 2. Okay? So that means my answer here is my x value is 2, my y value is negative 2. In an equation form, I'll give you y equals whatever. You input whatever I tell you to do for the x, because it says x is 2. So we input the 2 into the x, or we substitute. And then we get an output or an answer of -2. This is what we're looking for. So this basically tells me this is a function because that one input has exactly one output. If I plug 2 in here, yeah, I'm not going to get any other answer other than -2. This is it via equation form. Well, we're talking about functions. So if we look here, if you ignore this f parentheses x, I'm going to talk about it here in a second. You got 3x minus 8. If you ignore the y equals here, you got 3x minus 8. They're the same exact thing, right? But this one has the f parentheses x. This one just has a y. They are interchangeable, okay? Y and this is called f of x. Y and f of x are the same thing. They're interchangeable, right? Think of them as socks. You have multiple different color socks or whatever like that, but they're interchangeable. You can put on any of the pair of socks. That's what's here. You can have y, you can have an f of x. You're going to learn here eventually you can have a g of x and h of x. All this means is basically we have this function, 3x minus 8. We want to know what would be its output. Well, if we look here, we did x equals 2. Now I have this f of 2. What this tells us is this 2 is in place of this x. And that's what we're going to do in this equation. We're going to input that 2 in place of the x. So we're going to do f of 2 equals 3. Rather than x, we're going to put 2 minus 8. Then we solve. 3 times 2 is 6. Add the minus 8. And we get an answer of -2. So f of 2, the function of 2, is -2. So anytime I input 2 into this function, 3x minus 8, I'm going to always get -2. That's all this is. F of x basically says f of x, meaning we have the x. F of 2 means in place of the x, we're going to put the 2 because that's what I replaced it with. It's function notation. We're looking to see the function. You may be sitting there going, Mr. Harris, what are we talking about here? We're gonna build on this and we're gonna put it all together as we go. So let's do an example. 4, f of x equals -4x plus 7. Find each value. All right, so let's solve these together. So here's our function. Here's what we're trying to find. We're trying to find f of 3. So we're going to plug in -4. In place of x, we're going to put 3 plus 7. So let's just do some math. We ignore the f of 3 equals, so it's -4 times 3. -4 times 3 is -12 plus 7. So then f of 3 equals, well, -12 plus 7 is going to give me a -5. So that means we have a ordered pair of 3, -5. Because when x is 3, our output is -5. What about this next one? F of -4. Let's do that one. F of -4 equals -4 times -4 plus 7. All this integer work that we did before is coming into play. We have -4 times -4. 4 times 4 is 16. Negative and a negative is a positive. So we have a positive 16. We have 16 plus 7. So f of -4 equals 16 plus 7 is 23. So when our input is -4, our output is 23. This is how we do it. We take the function given to us. We take the value they tell us to substitute in for x. We input it, and we get our output. So here's an on your own. I'd like you to try this one on your own, please. So I want you to pause the video and try this on your own. All right, so for the first one, g of -2, you should have gotten g of -2 equals -20, with basically the ordered pair of -2, -20. For the second one, g of 5, you should have gotten 22, with an ordered pair of 5, 22. So when our input was 5, our output is 22. Let's look at one more. A little tricky here, but it's not terrible. F of -3 plus 1. This looks trickier than it is. When we see anything like this, we see f of whatever, g of whatever, and then we have a plus or minus a number. Solve the function first. So we have the function of -3. So we're going to do f of -3 equals -4 times -3 plus 7. Like I said, let's solve the function first. -4 times -3, that is 12 plus 7. 12 plus 7 is 19. Now, what it says is find the function and then add 1. So we're going to add 1. So then the answer is 20. Okay. So this one really isn't an ordered pair because we're not necessarily dealing with the full function. We're now kind of working with expanding off of it. And you'll see more down the line as we go what this is for. So f of -3 plus 1 is 20 because f of -3 gave us 19. And then it just told me to add 1 to it. So I get 20. Now let's look at this next crazy one. With f of 6 minus f of -1. Oh man, there's two different functions. Solve them as two different functions. So f of 6 equals -4 times 6 plus 7. -4 times 6, -24 plus 7. -24 plus 7 is -17. We're not done. Now let's solve f of -1. F of -1 equals -4 times -1 plus 7. So we're solving that function. -4 times -1 is 4 plus 7. 4 plus 7 is 11. Okay. Now, we're going to take our f of 6 and we're going to take our f of -1 and we're going to subtract the two numbers because that's what it tells us to do. It tells us to subtract. So -17 minus 11. -17 minus 11 gives us an answer of -28. So when you see all these crazy things, don't think of them as a whole thing. Find your function, then do what it says to do. So for when you add or subtract a number, solve the function, then add or subtract that number. When you have two functions minus or added to each other, solve the functions, then add or subtract them. So you saw an example. Now I want you to try this one on your own. So I want you to pause your video and try it on your own. All right, so hopefully on your own, you were able to get, for the first one, g of -3 plus 10. Hopefully you were able to get -16. So we did g of -3. You should have gotten -26. And then at the end, we add the 10 on, which would have given us -16. And then g of 7 plus g of -5. So for g of 7, you should have gotten 34. And for g of -5, you should have gotten -38. It says to add the two. So we have 34 plus -38. Here comes that integer math coming into play again. And we should have gotten -4. So this is an introduction to functions. Again, if you have any questions when we stop for time for questions, make sure you ask those questions.